Hello everyone. In this video, we'll discuss about summing and differential amplifier. Before seeing the detailed expression, we'll just start with the applications of these two. Summing amplifier is nothing but adding the two signals or two voltages or two frequencies. Okay. Here, one of the applications of summing amplifier is audio mixers, right? Audio mixer is nothing but we are adding the two audio signals. Okay, this is our basic applications of summer. And next one is signal conditioning, analog signal processing, control system, load cell signal conditioning, temperature compensation, instrumentation amplifier. These are the applications of summer. That is, we'll add these here. So the summer is nothing but it is a circuit that gives the output which gives the sum of the input. So we'll sum the input which is given and we'll give to the output. Okay. Here we'll see inverting and non-inverting amplifier. So what is inverting here is normally in operational amplifier we have two terminals, right? One is the inverting terminal, another one is non-inverting terminal. The inverting terminal is represented by minus symbol and the non-inverting terminal is represented by the positive one. So inverting terminal is negative and non-inverting terminal is positive. So in inverting amplifier, the input will be given, the n number of input, whether it is can be 2 or it can be 3 or it can be 4. Okay, the n number of inputs is given to the inverting terminal. Okay, and then there is a feedback resistor and we have a compensation resistor. The compensation resistor is used in order to avoid the bias current. That is what is meant by bias current. I think we have explained in previous videos. It is normally the current between these two inverting and non-inverting terminals should be 0, right? But because of some manufacturing problems and all, it cannot be ideal, right? Every electronic instruments cannot be the ideal one. So there will be some current. In order to avoid that bias current, we are including a compensation resistor. Okay, so that's all with the inverting amplifier. So this is the circuit diagram, right? The input will be on the inverting terminal and the output at the V0. Okay, so how will be your output here is normally when you are giving the sinusoidal input, your output will be inverted one. Okay, you'll get the inverted output with amplified one. Okay, there will be two processes happening here. One is amplifier, another one is inverting. Okay, next one is the non-inverting amplifier. So here what happens here is it will add the signals, a number of signals, and it will give the output with the amplified one, but it will not be the inverting one. It is non-inverting one. The only difference we'll make here is the input will be given, right? The input, right? Input will be given in non-inverting term. Okay. So you can just check here. This is your non-inverting terminal, right? The input V1, V2, V3, right? These three are given in non-inverting terminal. And the inverting terminal is grounded and the feedback is given. Okay. Here the output will not be inverted. Okay, it will be as same as the input, but it will get amplified. So the gain, right, the gain of the inverting amplifier will be in negative because we are getting inverted one, right? So your gain will be minus RF by R1, that is feedback resistors by input resistors. Next, for non-inverting amplifier, your feedback, your gain will be of 1 plus RF by RA. Okay, you can just go through this question. Identify the below mentioned circuit which is non-inverting amplifier circuit. You can just check this. Which is the non-inverting one? You can just check. First one is okay. We have just brushed out the previous one, right? Inverting and non-inverting terminal. Whether we have used diode in these two? No. So the first option will not be possible. And second, just you can go through whether you can see plus minus where the input is given non-inverting one, right? So we need non-inverting amplifier. So this one will be the right answer. So your option second one is your right answer here. Okay. Next comes the differential amplifier. What is mean by differential amplifier normally? The name of meaning of the name differential. It's difference or differential. Difference is nothing but the difference between the two inputs, right? So we'll take the difference between the two inputs and we'll amplify it. So that is the application of the, so that is the process of the differential amplifier here. So the application here is, first one is motor control. So you can it is used to control the motor in various aspects, okay, and it is used in biomedical applications. For example, EEG, ECG, the differential amplifiers can be used. Next one is the differential filter. So these are the applications of differential amplifier. You can just refer the circuit diagram. We have two inputs here, right? V1, V2, okay, and we have a feedback resistor, okay. The input, one input is given in inverting terminal, the other input is given in non-inverting terminal. You can just refer this. One is given in inverting terminal, the other one is given in non-inverting terminal. Okay. Now, how will be our output? Okay, that is the thing. For example, when we are giving two inputs with same phase, that is same magnitude and same phase, what will be our output? It's a differential amplifier. When we have same inputs, what will be the difference? It will be 0, right? So when we have same inputs, the output will be 0. But when you have different inputs, the difference will get amplified and you'll get the output. Okay, this is the differential amplifier. So how will you calculate the output voltage? That is nothing but the difference between two voltages, right? So we can just go through these. So what are the content we have discussed here is summing amplifier. In summing amplifier, we have gone through inverting and non-inverting amplifier and its application of summing amplifier. Next one is differential amplifier. The summing amplifier will add the n number of inputs and will give and can obtain the output. Okay. In that, inverting and non-inverting amplifier, right? In inverting amplifier, the input is given to the inverting terminal and because of that, you'll get the output as the inverted one. Okay, inverted one, that is in positive. If you are given in positive, you'll get negative. So that's the thing. Next, non-inverting will give the input in the non-inverting terminal and you'll get the output as a non-inverting. That is, if you are given positive, you'll obtain as positive. Okay, and your waveform will not get changed. And next one we have seen differential amplifier, right? So differential amplifier is nothing but the difference. We'll check the difference between the two voltages and we'll amplify. Okay, that's all with the summing and differential amplifier. Thank you.